Take a minute of your time and imagine the world without mathematics. Teaching platform, this is Mr. Mlonga, aka the teacher. My pupils calls me the teacher. We are here to do mathematics indeed. Be ready for the lesson that is coming forth. If you are new to this channel, you are welcome. Please subscribe so that every time we post a video, you are the first to be notified. We'll be posting videos every day. Talk about integration of trigonometric functions. For us to do that, we first of all have to consider the standard integrals of each trigonometric function. So we can consider four of them, starting with A, the integral of cos x dx, meaning integrating this cos x with respect to x. The function, the trigonometric function in this case is cos x. Now we have to integrate this one. When you integrate this, the standard integral comes out as sine x plus c, where c is some constant. The second standard integral is going to be b. So we have the integral of sine x dx. This means that you are integrating sine x with respect to x. So the standard integral comes out as a negative cos x plus c, where c is some constant, of course. Then we also have the standard integral of sec squared x dx, meaning integrating sec squared x with respect to x. The standard integral is going to be tan x plus c. Of course, c is some constant. Then we also have the fourth, the standard integral of cosec squared x dx. The standard integral is actually going to be equal to negative cot x plus c. These are the four basic standard integrals of trigonometry, and we should be able to use them, apply them in the next questions to come. On the solving board, we have this question 1, in which we are going to use the standard integrals that we talked about. It says find the integral of 3 sine 2x dx. So to provide a solution to that, we'll say let u be equal to 2x. If this 2x is equal to u now, we can differentiate this u with respect to x. So at this point, we are using the concept of differentiation. I'll soon show you why we are using that. If we have to find du dx, then it means du dx is going to be equal to the number 2. When we differentiate this 2x, it will just be a 2. Then we have du dx. Let us make this dx the subject of the formula. So this is more like over 1, yes. Cross multiply. When you cross multiply, you are going to have dx is equal to du over 2. When you cross multiply and divide throughout by 2, you are going to find that. Then from there, we have found this dx. This is the reason why we are differentiating, so that where there is dx, we'll write this. So we'll substitute into that. We'll say the integral of 3 sine. This 2x is equal to u, so you write u there. Then this dx is equal to du over 2, so you write du over 2 there. At this point, this 3 is a numerator, this 2 is a denominator, so they make a fraction. Hence what we have a 3 over 2, then the integral of sine u du. This is because the 2 is already here, the 3 is there, so we have a 3 over 2 like that. Then from there, we can now integrate this. If we have to integrate that, we are going to now have 3 over 2 in brackets like that. What is the integral of sine u? It will give you a negative cos u, according to what we did under the standard integrals. So then how is the answer going to be? The answer is going to be 3 over 2, open brackets, minus cos. Our u in this case is 2x, so you put a 2x like that. Then when you integrate, we put plus c. So then, from there, you can open the brackets. When you open the brackets, you are going to have a negative 3 over 2 cos 2x plus c. This is an improper fraction. You can write it as a mixed fraction. When you write it as a mixed fraction, it will be negative 1 over 2 cos 2x plus c. This is the final answer. We have found what we are required to find. From there, we can have another question. On the solving board, we have another question. The question is to find the integral of 2 cos that with respect to x. So to do that, first of all, let this in brackets be equal to u. So we say let u be equal to 3x plus pi over 3. After equating this u to that, then differentiate this. So at this point, we are using the concept of differentiation. So if we have to differentiate this, we are saying that then du over dx is going to be equal to, when you differentiate this with respect to x, it will just be actually a 3. That is differentiation. Then after differentiating it, let us make dx the subject of the formula, because this is actually over 1. When you cross multiply at this point, you are going to have 3 dx is equal to du, just like that. Then divide by 3, divide by 3. You have this going with that, and dx is going to be equal to du over 3. The reason why we had to let this be equal to u, we wanted to differentiate it. Why did we want to differentiate it? We wanted the x to appear. Why did we want the x to appear? We wanted to substitute for the x there, so that where there is this dx, we write du over 3. That's the concept behind. So after doing that, then we can now substitute into that. So if we have to substitute, then we are saying the integral of 2 cos this 3x plus pi over 3 is now equal to u. So cos u, then this dx is equal to du over 3. So we have du over 3 like that. After doing that, these 2 and that 3 can form a fraction, because this one is a numerator, this one is a denominator. So if we follow that, then we can write them outside. Here we say 2 over 3 integral of cos u, this u, then 3 is already there, so du there. After doing that, we have to now integrate cos u. To integrate cos u, the integral of cos u according to the standard integrals is actually equal to sine x. So we say sine, so 2 over 3, then sine x, which is in this case, the variable we are using is not x, we are using u. So it will be sine u, then plus c. When you integrate, there's supposed to be a constant c. At this point, the next step is to actually substitute, because this u is known. So we are saying 2 over 3, then sine u is known. U is this 3x plus pi over 3. So we have a 3x plus pi over 3. This is a number 3. So 3x plus pi over 3. 3x plus pi over 3. Then plus c. This is the integral we are looking for, and at this point we have integrated correctly, applying of course what we used in the standard integrals. So it's very important that you get to know the standard integrals, and you should be able to substitute them correctly. Remember, on the way, as you let u be equal to something, remember you have to actually look at how you're going to substitute for this dx. So to substitute for this dx, you first differentiate u with respect to x, then you make dx the subject of the formula. After making dx the subject of the formula, then you are ready to do the substitution. This is sign, so there must be a dot there to show that we are dealing with I. This marks the end of our lesson. Please, if you have not subscribed, this is the time to do so, because every day we'll be posting videos, and it's important that every time we post a video, you are the first to be notified. Where you need to comment, you need to ask something, do not hesitate. We value your support, we value your contribution, be it positive or negative. Welcome once more, and thank you very much for having watched the video. Please share the video with others. Let other lovers of mathematics enjoy the mathematics that we are doing on this platform. It's mathematics all the way until Jesus Christ comes. Take a minute of your time and imagine the world without mathematics. We cannot be able to calculate or count the time without the use of mathematics. The calendar that we use is a product of mathematics. We only get to know that this is the year 2020 by the use of mathematics, by following the calendar mathematically. The population of any country is a product of mathematics. You only get to know that it takes 9 months for a baby to be born through the use of mathematics. In the medical field, temperature is calculated using mathematics. In the business world, profit and loss is only appreciated by the use of mathematics. A bricklayer uses mathematics to calculate the number of bricks needed for that construction. A carpenter uses mathematics to calculate the gradient of the roof before the roof is put up. A policeman has to count the number of prisoners in that police cell through mathematics. A thief should be able to calculate the hypotenuse of that brick wall before falling off that brick wall. We all need mathematics. Mathematics runs the world.